For this example, we're given two functions, f of x equals 3x minus 2 and g of x equals negative 1 half x plus 5. So they're both lines, and there's a few things that they want us to solve for this problem. So for the first part, we're solving f of x equals 0. Essentially, we're trying to figure out what is the x-intercept of this function. So we can just take our function 3x minus 2 and set it equal to 0. So to solve this, we add 2 to both sides. 3x equals 2. Divide by 3, and we get that x is 2/3. So we get the ordered pair 2/3, comma 0 for our x-intercept. 2/3, comma 0. So that's our x-intercept. For the next part, we're trying to figure out where is our function f of x negative. Where is it less than 0? So we'll take a look at what this means graphically in just a minute. But to solve this algebraically, what would we do? So essentially, we would just solve the inequality 3x minus 2 is less than 0. So the solution is very similar to what we had when we were just solving for it equal to 0. So you add 2/3, or sorry, add 2. So we get 3x is less than 2, divide by 3, and we get that x is less than 2/3. So we get the same value of 2/3, but now it's saying for all values less than 2/3, our graph is going to be negative. And again, we'll see that when we look at it in the graph in just a minute. But it's saying for all values from 2/3 and below all the way off to negative infinity, our graph is going to be negative or below the x-axis. This next part is asking us to figure out where is our function, where are our two functions equal? Where does f of x equal g of x? So we just take the values for our two functions and we set them equal to each other. So 3x minus 2 equals negative 1 half x plus 5. And then we solve. So add 2 to both sides. Add 2 to both sides. We get 3x equals negative 1 half x plus 7. Add 1 half. So 3 over 1 plus 1 half. Remember 3 over 1, that's the same as 6 over 2. So 6 halves plus 1 half is 7 halves. So we get 7 halves x equals 7. And then multiply both sides by 2 over 7 so that we can get that to cancel. So 2 over 7. And these reduce, and from this we get that x equals 2. So we know that when x equals 2, these two values will be the same. But really, when you're solving an equation and you're figuring out where is our function equal, what are you trying to find? Well, this is just really finding the point of intersection. So just having the x value isn't quite enough. So we need to take this x value and plug it back into one of our functions to figure out the y value. So I'm going to use f of x. I think it's probably a little bit easier to solve this. So what is f of 2? So plug 2 back in. That's 3 times 2 minus 2. 3 times 2, that's 6. 6 minus 2 is 4. So we get the ordered pair 2, 4. So that is the point of intersection. This point is where our graphs are going to be equal. That's where they intersect. For this next part, we want to know where is our function f of x greater than or equal to g of x. So algebraically, we are going to do very similar thing to what we did in part C, except now we're figuring out where is it greater than or equal to. So 3x minus 2 is greater than or equal to negative 1 half x plus 5. So there's actually another approach that we can take to solve this problem. If we want to get rid of all of our fractions from the very beginning, we can actually just multiply everything by 2. And what that's going to do is that's going to get rid of our fraction here. So you have to remember to distribute the 2 in. And that'll give us a new equation. 6x minus 4 is greater than or equal to negative 1 times 2 or negative 1/2 times 2 is negative 1x, and then plus 10. And now we can solve this equation. So add 4 and add 1x to both sides. And we get 7x is greater than or equal to 14. Divide by 7, and we get that for x values greater than or equal to 2, our function f of x will be greater than g of x. So for all values of x greater than or equal to 2, the function f of x will be greater than or equal to g of x.